Cool breezes, sea breezes, come off of the ocean and intersect with the warm land. That warmth allows that air mass to rise. So the warm air is rising, and when it rises, it creates a low pressure system. Low pressure is going to be underneath it because the air is going up, so low pressure below it. As that air gets up into the atmosphere, it's going to cool off, and that cold air is more dense and it's just going to sink. So you can get this rotating convection cell of air. If you look at it in kind of a cartoon here, we have warm air. Let's see. We'll start here. One warm air rising, that's what's over the land. That's going to create a low pressure. It gets into the atmosphere and it cools, and that cool air is going to sink. When that air is sinking down, then we'll think of it as pushing down on the earth. It's creating a high pressure system. Wind, the reason wind blows is because it blows from a high pressure to an area of low pressure. So high pressure to low pressure is the wind. Now let's look at that, what that looks like then for our ocean basins. Okay, so this is a map that is indicating pressure. The yellows and oranges and reds are high pressure, and the cooler blue colors are low pressure. So think about which way the wind would blow. Right, from high pressure, those H's, to the L's, to the low pressure. So we have what's called pressure gradients, and that is that movement of air from high to low, and that is wind. All right, so I'm going to turn my face off for a sec here. Let's talk pressure again. So the high pressure systems or zones are going to be in the mid latitudes. So through here, these are sunny places that are dry and sunny. And the here again, dry and sunny. The low pressure areas are wet and stormy. So you can think of that like the rainforest kind of areas. The tropics and high latitudes as well, wet and stormy. Okay, that's the pressure over our ocean basins. So remember, the wind is going to blow. Let me turn off my face again so you can see here. Winds are going to blow from high pressure to low pressure. So those red arrows indicate the direction that the wind is blowing, from high to low. All right. If we had an Earth, so here's the Earth, and let's say that there's no tilt to it and it's not rotating, but we still have that differential heating. So coming right in at the equator is some unit of solar radiation, but that same amount of solar radiation is spread out across the poles. Okay, so we have the same amount of heat hitting, so we're going to have hot air around the equator and cooler air at the poles. So that warm air is going to rise at the equator and then sink at the poles and then travel along the earth, heat up, rise and sink. This is a convection cell. So remember, this is a real simplified model that would only be the case if our earth were not rotating, but alas, it does rotate. So it's rotating earth on its axis. The atmosphere is not rigidly attached to the earth. I know that doesn't seem like a profound statement, but we have to think of the atmosphere as kind of like just this outer envelope of gas, right? So the Coriolis effect is an apparent deflection of moving air relative to the Earth's surface. So the air is going to be deflected because the Earth rotates. And it's due to the variations in speed of the rotation of the Earth at different latitudes. So look at this graph over here. This is actually, there's the only reason there's two columns is one is kilometers per hour and the other one is miles per hour. So at oh, I am recording. Hi. At the poles at 90 degrees, the Earth is not rotating, right? Well, there's no motion. But as you get down to the equator, it is going to be going very fast, 1,000 miles or more miles per hour. So very fast rotation because it has a much further distance to go at the equator and then not moving at the poles. So very much a slower rotation at the poles. Because of that, the air is deflected. And that deflection is a couple slides here about the Coriolis effect. The Earth is rotating. The objects tend to get deflected from a straight path. In the northern hemisphere, objects, and the wind, let's say, is deflected to the right, and the southern hemisphere is deflected to the left, and at the equator, not at all. Okay. The primary, this then is the primary control of the direction of wind patterns. So wind is deflected. Surface ocean currents. So the wind is going to be deflected. That movement of air from high to low pressures deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And so are the surface currents. So here is what that looks like then. So the first globe we looked at that was blue had a bunch of straight lines and one giant convection cell. Well, here we see that there are these belts of wind, and let's talk about the names of them if you're looking at that. So like, for example, these westerlies, the wind is blowing from the west to the east. And in the trade winds are here around the equator from 30 degrees north to 30 degrees south. And then we have easterlies at the poles, and the air is blowing from the east to the west. Okay, so this is still based on those pressures, the high and the low pressure. Let's say again that the high pressure is descending air, clear skies, and low precipitation. And the low pressure is ascending air, where it's going up into the atmosphere with clouds are going to be forming and heavy precipitation. So going back over here, we have the doldrums, or the area where these pressure systems are coming together, and there's really going to be no wind in the doldrums. Moist air rises over these low pressure areas, the equator, and the high latitudes. Here is that rising of the air and creating low pressure, and then here again over high latitudes. The mid latitudes, so this area 30 degrees north and 30 degrees south, is going to have sinking air. So that air is going to be descending, and that will be areas where we have dry air and desert environments. Okay. All right, so the three different sets of convection cells, let's see, 1, 2, 3 bands of convection cells are the trade winds by the equator, the westerlies in the mid-latitudes, and the easterlies at the poles. Okay, the doldrums. The doldrums are this area of convergence, and it's areas where we're going to have rising, so there's going to be low pressure, and at the doldrums there's really going to be no wind. Take some time, if you will, to click on this windy link here, and it will take you to a website that shows wind patterns across the earth.